Good afternoon all. This is Tim, another film from the workshop. This time I'm showing how to fit SLS nylon parts together without recourse to glue, or at least the way I did it. On the turrets I decided early on to use this method of fixing with machine screws and bolts and cutting threads because it enabled me to back out of an assembly if I found that I'd painted myself into a corner or had to correct something, which did happen several times, so it was a useful thing to have done. It does take more time, obviously. You've got there's a lot of work drilling and tapping threads, and it is on occasion bloody fiddly, but it does enable you to get a nice detailed result that's very strong. Anyway, here we go. So there are several ways of doing this. The first one I'm going to show you is using an insert. These are available from Alibaba, and if I drawing pin for scale, so what you've got there is a drawing pin, an M1.6 machine screw and a little brass fitting that's got an internal M1.6 thread and little flutes that run along the barrel, left to right as you look at it. And when those are pressed into an undersized hole, that locks the thing rotationally so that you can apply the screw. If you really wanted to make sure of it, I suppose you could glue it in, but I've not found a consistently good way of doing that, and they don't seem to let go, so it's a good solution. These are actually not the smallest ones you can get, which are these. It's hard to pick up one of them, but you can just see there 3 of the same thing but with an internal thread of M1, and they truly are fiddly to use, but it is possible, and I have done it quite a lot on the turrets. So let's put those back in their boxes. Now I know that I need to cut an M2.4 thread, drill an M2.4 hole in order to take that, and I also know from measuring it that it's exactly 4mm end to end. So what I'm going to do is just bring the drill down, zero it, go down to 4.5 or so, lock it at that point, and then the drill will stop at the correct depth. I wouldn't recommend touching the drill bit normally, but as it's so slow, it doesn't hurt. So, but do be cautious about doing that. So then all you need to do is to position it over the hole so that it's standing perfectly upright. Put it on a hard surface, and then with a suitable size hammer, give it a smart tap. May need really using there. Yeah, so that's now flush, and as you can imagine, it's not going to let go. So if I take another piece of plastic, this one's already got an M1.65 clearance hole in it, which is fractionally oversized to the machine screw going through, and then that will positioned over that, screw quite happily into that insert. So that's one way of doing it. The other mechanism is via cutting a thread, and I know from a sheet like this, which you can download anywhere from the web, that an M1.6 thread requires an M1.5 pilot hole. So, these are rather fun. These were pens from my daughter's extensive collection of felt tip markers that had dried out or failed. I hooked the ink out and turned them into little packets for small drill bits, and of course being colour coded they're ideal because you can just lay hands on the right one straight away. when they dispense, there's several in there, they normally only dispense 1 or 2 at a time, so it's easy to... Now, in this particular instance, because this drill will only take down to M1.5 drill bits, if it was any smaller than this, I'd need to use one of the pin vices, which I'll show you in a moment. So what I'm going to do here is I'm going to drill clean through this. So again, come down, set it down, just down into the baseboard, and then I know it will go straight through. It won't go through in one go, so I need to go down a little bit, back it off, go in again, back it off, go in again, back it off. And that's gone through. Now normally when you do these you get a little bit of a burr form. It's alright on that side, but on the back you often get a little bit of a burr, so just clean that up with a scalpel. This is a pin vise, so essentially it's just a chuck with a handle on it, and in there is M1.6 tap. So if I now put that in the hole as perpendicular that way and that way as I can, and start to turn it with a very light pressure, it'll start cutting its own hole and it will self-center. And then every 2 turns or so I back it off half a turn, so I'm turning this clockwise and then backing it off anti-clockwise, and that takes the spoil from the tap and puts it into special channels within the tap so that you're not trying to cut it again, and that reduces the amount of torque required to operate the tap, cuts a clean thread, and more importantly prevents you from snapping the tap. Now with these M1.6 taps, I don't think I've ever broken one of these, but once you go down to the M1 taps it's very easy to, and it's that reversal where you reverse the rotation that's the danger point. That's when you'll snap them. If you're doing a project like this, I strongly recommend that you ask any 3D printing company that's using this material if they can put offcuts aside, anything that doesn't work, prints incorrectly and that otherwise